users from different tenants could see each other's data in shared dashboards. A single ownership grant on a schema cascaded privileges to every table. Welcome to this deep dive into Snowflake security. We'll cover RBAC, network policies, authentication methods, and dynamic data masking. By the end, you'll be able to design a secure Snowflake environment that scales with your organization, covers what you need. Snowflake Security is a multi-layered framework that uses RBAC, network policies, authentication methods, and data masking to protect your data warehouse. Think of it as a high-security office building. RBAC is like assigning badges, network policies are the guest list, authentication is showing your ID, and data masking is a privacy screen on your laptop. RBAC is the foundation. Instead of granting privileges directly to users, you create roles, assign privileges to those roles, and then grant the roles to users. Snowflake has a hierarchy of system-defined roles, starting with ORG-ADMIN at the top, followed by ACCOUNT-ADMIN, SECURIT-ADMIN, USCR-ADMIN, then roles like SYS-ADMIN and public, with privileges inherited down the chain. You can also create custom roles for fine-grained control, and they inherit privileges from parent roles. Let's create a custom role for a data analyst that can only read from a specific schema. We'll create the role, grant usage on the database and schema, grant select on all tables, and then grant the role to the user. Here's the sequel to create the role and grant privileges. Note the order: first usage on the database, then on the schema, then select on tables. Finally, we grant the role to the user and verify with show grants. A common trap: granting ownership on a schema to a custom role. Ownership cascades to all tables, enabling unintended privilege escalation. The fix uses manage grants on the schema, which limits control to schema-level grants and prevents cascading table ownership. Traffic from the internet is inspected by a network policy. You define allowed and blocked IP lists and apply the policy at the Snowflake account level or to individual users. A user-level policy overrides the account-level one. Here's how to create and apply a network policy. We define allowed IP ranges and a blocked IP, then set it at the account level. For a specific user, we can override the account policy. Use show and describe to inspect policies. A common gotcha: IP4 and IP6 are separate in network policies. Here, the before code only allows the IP4 range 192.168.10.24, blocking all IP6 traffic. The after code adds 0 to permit any IP6 address, ensuring both protocols are covered. Always include both if needed. Snowflake supports password authentication as a baseline, but for production enforce stronger methods: SSO, OAuth, and key pair. Use SSO with MFA for humans and key pair for service accounts. Avoid long-lived passwords altogether. Key pair is ideal for automated processes. Here's how to configure key pair authentication. First, generate an RSA key pair using OpenSol. Then set the public key for the user with alter user. Verify the fingerprint and configure the client to use the private key. Dynamic data masking lets you obfuscate sensitive data at query time based on the user's role. The underlying data remains unchanged, but unauthorized users see masked values. You can use case for multiple conditions, while the original data is always preserved intact. Here's a masking policy that uses current role to show the full email only to admin roles. For others, regexp replaces the local part with asterisks. Apply it to the email column, then test with different roles. Masking policies only mask data values, not column metadata, so describe table still reveals names and types, as show columns confirms. To restrict visibility, use secure views. Here's the chain reaction. The developer granted ownership on a schema to a custom role. Ownership cascaded to all tables in the schema, including those containing sensitive customer data. This violated the principle of least privilege and led to cross-tenant data exposure. The fix involved revoking the excessive privileges, implementing row-level security using secure views, and enforcing least privilege with custom roles. Instead of ownership, use specific grants like select and usage. This prevents privilege escalation and isolates tenant data. This is the exact line that caused the incident. Granting ownership on a schema cascades to all tables, leading to unintended data exposure. The correct approach, as shown in the fix, is to grant usage instead, which limits schema access without cascading to tables. Always use specific privileges like usage. When debugging security issues, start by checking the user's roles and the grants on the object. Use show commands to verify privileges. If a user can't see a table, ensure the role has usage on the database and schema, and select on the table. Let's review common interview questions. RBAC uses roles to manage privileges. Network policies restrict IPs. Dynamic data masking hides sensitive data at query time. Let's recap frequently asked questions. Users and roles are distinct. Only one masking policy per column. To remove a user-level network policy, use unset. To summarize, implement RBAC with custom roles and role hierarchies, use network policies to restrict IPs, choose authentication methods wisely, apply dynamic data masking, and regularly audit privileges and access history. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.